Hey everybody, this is Mr. Bells. This is your COVID first trimester 2020 stats test review video. I know we didn't get a lot of time to be able to cover the stats, so hopefully you've watched some of the extra videos that I put in there and about what you need to do. So these are the things that you need to know for sure to be able to do on the tests that we're doing. Again, that's going to be a for the people who are watching this, it's going to be a Google form one. Make sure that you have a graphing calculator, that you're very comfortable being able to use all the functions of this thing. Okay, doing a lot of the questions that we have by hand, not so good. So here we go. What are the first things that you need to be able to know how to do? I've got a series of questions that are true or false ones. That deal with box and whiskers and histogram. So I'm gonna kind of draw some pictures out for you right now on the paper because I think it's easier to be able to see that. Here we go. So what are some of the things that you're gonna be expected to know? So let's say that I had this right here, and I get a whisker here. And I got a whisker here, and then I got this thing right up here. Okay, so this again is a box and a whisker plot, and we should know some basic stuff about this. One, this right here, this line right here is the median, and this line right here is Q3, and this line right here is Q1. This is the minimum score. This one out here is a maximum. However, this point out here is also called an outlier because of the fact that it is more than 1.5 times the interquartile range, that being the length of the box, away from the box. And then whenever we have an outlier, what we simply do is we put the whisker to the next score that you'd find sequentially as you go down. Okay. So if you just look at this, this looks pretty symmetrical. Let me focus that a little bit better. This looks pretty symmetrical. However, you can see in here that this box, right, this section of the box, this upper half, is bigger than the smaller half. However, when we're talking about the actual number of people, say that there was 1,000 different people spread out in this group, there really would be 250 people in this range and 250 people in this range. It just means that the 250 people in this range, whatever the score, whatever the data is squished together a little bit more. Okay? So I can't tell individual scores in this thing, but I can tell basic trends for this. And yeah, this is unique. If it really was 1,000 people in here, to only have one outlier, that's pretty amazing. Okay, so can I do this on my graphing calculator? Absolutely. So if I was to go to on like this, and I go to stats and edit, I got a whole bunch of data in here. This is my IQ data that I've already sorted. Just a quick reminder on this stuff. If I go to stat and calculate, I can do one variable stats. I go ahead and push that L1 and I hit calculate. These are my one variable stats, so I'll kind of go through this real quick. Top thing, X bar is the mean. Again, X bar and this symbol right here, mu, they're pretty much synonymous for this. If you look in the textbook, it'll talk about this quite a bit. The next one we really want is the one right down here with the little circle thing with the top hat. And that's a standard deviation. Standard deviation. And that, again, measures the spread in the data. What it's like there. And then it goes min, Q1, Q2, or the median, which is the same thing, Q3 and max. So these are kind of the numbers that you see here. Again, this data set that I just randomly made up here is not this. There's only 50 people in this. We made up 1,000 people in this thing up here. But how do I get it to show up on my screen? So I'm going to go second y equals, and you can see that I have plot number 1's off, plot number 2's on. I'm going to go ahead and turn plot number 1 on. I'm going to do a box and whisker plot, that one right there. I'm going to mark it with a box. Good deal. Now, what I want to do is I want to see it. So if I want to see it, I need to go to my window. So my X data, in this case for this set, this is not in there, right? These are the IQ scores. So the IQ scores went from about 50 to 150. I think most of them were in that range. And we're going to group them by groups of 10. So 50 to 60, 60 to 70, 70 to 80, and so on down the line. That's what that means. And I can go ahead and hit graph. Now it says invalid dimension, something about plot 2. So I'm going to go to clear, and I'm going to look at my plots, and plot number 2 is on, and it says it wants L2 data. Well, I don't have anything in L2, so I'm going to go ahead and turn plot 2 off. Now I can hit graph, and you can see, hey, look, that's my data. Now it might have been that I was missing one on the high end, so let me put this at 170. Maybe we have somebody super far out there, and look, I was missing that. So again, these things are outliers, but again, each one of these sections should have 25% of your total data in there. Good? Okay, so there's going to be some questions on box and whiskers. So what are histograms? Histograms are the same set of data as what I had on the things, except now we're going to say that in these ranges, we have a certain amount. So maybe there's 175 in this range, and there is 200 in this range, and there's 295 in this range, and maybe 180 in this range, and whatever it is. But it's going to give you two things. It's going to give you a gap right here for how big of a spread of numbers you want to pile in there. And then it's going to give you a vertical thing. So 50, 75, 100. Let's make that 125. So on down the line. And then it's going to give you a vertical stack. So there's going to be intervals here on the y-axis, which is simply going to count how many fall in each one of these categories. And then the X scale down here is going to show you how we're going to group them by. So let's go ahead and take the same data again, because a lot of you have this data in there already. So I'm going to go to my stat plot. I'm going to turn it on. I'm going to change this one to histogram, hit enter, and then I'm going to go ahead and hit graph. And you can see on this right now that I've got a pretty nice distribution here, but I can't see the tops of these things. And the reason is because my Y only goes to 5. Well, that means I have more than 5 in some of these categories. So if you watch, I'm going to hit trace, and this one shows me I have 1 between 60 and 70. This one shows me I have 2 between 80 and just below 90. 4 there. Ooh, there's 7 there, and there's 14 there, and there's 10 there, and there's 9 there before I come back down again. Remember, I'm only going to 5, so all 4 of these columns go further off my screen. So I'm going to go back to my window. I'm going to change my Y max. Remember, 14 was the highest, so if I go to 15, now I should see all of those in the distribution. Cool? Now, if I wanted to, I can, instead of grouping these ones by 10s, I could group them by, say, 15s, and now I get a totally different distribution. And now on this fourth column, you can see it goes up to 18. So I really want to go a little bit higher than that. Okay, so I'm going to go 180 here. I'm going to go to 20 here, and then you can see that. Good deal. So again, that's a histogram. That's how histograms work. Both of these situations, box and whisker plots and histograms, only deal with one variable. If it was a normal section, we would have had more time to be able to do some more stats, and we would have talked about 2 variable statistics and scatter plots and regression lines and all that kind of stuff, which is in one of my videos, but you didn't have to know for that. Okay. So you need to know box and whisker plots and how they work. You need to know histograms and how they work. I do have a separate video that breaks it down even more detailed on both of those things. You also have to know basic things. So if I gave you numbers 14, 20, 36, 48, and 52, and I said, hey, what's the mean, the median, the mode, the range? You should be able to do that for any of this data, and you can do it by hand, or you can use your handy-dandy graphing calculator and do it that way. But I also want you to be able to understand some of this. So if the mean of this was, say, x, whatever this number is, or let me use w. So it's some number w, the mean of this. Now, if I was to add a number in there, like say 70, so I'm picking a random new number 70 that I'm going to put in with this data, and I ask you, what does that do to the mean? You should tell me that it does this to the mean. It raises the mean. It also raises the standard deviation, which means there's a bigger spread in this data. Okay, so what would make the standard deviation go down? So question, if I put the number 2 into this data instead of 70, if I put the number 2 in, would that make the standard deviation go down? And the answer would be no. The standard deviation would actually go up with the 2, because that means the data spread out further. Okay, it would make the mean go down because that's an average. Average takes into account all the numbers and divides by how many numbers there are. So kind of have an idea of what means and standard deviations do for the data set. Okay. I do have some questions with some actual visual pictures with some things on them. Those are all those. Awesome. So you should be able to do this too. So let's see, I'm on stat, I'm edit, and we did stat, calc, one variable stat like this, and I did that calculation. And I know that the standard deviation is 17.25. Well, if I said to you, what if Albert Einstein joined this group? So we're like, oh, Albert Einstein, he's a pretty flippin' smart person, right? So we're going to go down here, we're going to add Albert's score in here, right? There's 50 of them, yes, 50. Okay, so here we go. So let's say Albert Einstein has an IQ score of 182. So I put that one in there, and I go stat, calc, and I do one variable stats again, and you can see the standard deviation definitely went up, right, to 19.3. However, the average IQ score also went up. So if I ask you to throw a data point in there and tell me how the change occurs or what it occurs, you can always just use your calculator to do it. Just make sure, if I ask a new question with it, that you remove any of the old stuff. And you can do that just simply by hitting the DEL key, watch delete, and poof, and that one's gone. Okay? Awesome. Double check that you typed in the stuff right that I gave you in the questions. Okay, so there's a bunch of questions like that. I talked about today about percentile ranks, and we know that a percentile rank measures, like say that we had a whole group of people here. Maybe it was everybody in Kalamazoo County, that plays soccer. Good deal. And we were looking at their skill level for soccer. Okay, and John has a skill level rank of 6.11 for whatever we're going to call this, and he is in the 50th percentile. Let's say adults, just because I don't want to compare like somebody who's in a 7 and 8 year old group with somebody who's an adult. So again, these are only ones that play competitive soccer. So he's at the 50th percentile. Now, if you compared John with everybody in here, that means that 50% of the players would be better than John and 50% of the players would be worse than John. However, he might be at the 95th percentile if the group was all adults in their soccer skills, because there's a whole bunch of people that don't play soccer anymore. So you can see that 50th percentile, maybe that's not very good, but that's only when you're comparing it to people that are playing soccer. Whereas if you compare it to all adults, his percentile rank might go up, maybe to 95th. It might be even higher than that. Okay? And again, how do we figure out percentile ranks? We put the score. So how many people his score is greater than or equal to, not including him, out of all the people, and then divide that by the number of people. And times it by 100 to get your percent. Okay? So that was percentile ranks. And we talked about it in class that you could have a percentile rank near 0 and still be amazing. And what we used was the 100-meter dash, right? So in the Olympics, somebody's got to finish last in the 100-meter dash. So technically their percentile rank, because their score was greater than or equal to nobody's, not including their own score, divided by anything is still 0. So that, the person who finished last gets a 0 percentile rank, but literally they're one of the fastest human beings on the planet. It's just that their group, their small group, was very specific. Likewise, you could take a look at maybe another group of people. Let's take my mom, for instance. She was in something called a quilting group. And basically it's a social group for people to go, and they say that they do quilts, but they might not do quilts. They might just talk and eat, right? So it could be that she was at the 85th percentile for making quilts in that group, but literally she might have made 1 in a year. She's probably not even that good at it, but that's what they called their group. So they're not professionals. They really just want to have some socialization and snacking and stuff like that. So even though she might have had a high percentile rank, doesn't mean that she's really necessarily that super talented. Now, that's not to say that's the total case, but I'll give you another scenario. For volleyball, I sit on something called the All-State Committee, and I'm a region rep. So what I have to do is when we go look at all the best players in the state, I'm a region rep for Division I, which of course you guys know is the highest division in the state of Michigan. And that's what our volleyball team's in. So when we look at it, we have to compare all of our kids with all of the kids that are in D1 throughout the state. And that's for schools that have, let's just say, approximately 1,000 students or more. Okay? So we could have a kid in D1 that might be the best player in the county. Good deal. But if you look at some other counties, if you look at the Grand Rapids area, if you look at the Detroit area or the Detroit suburb areas, man, there might be some really, really good players in those areas. So it's just depending on the size of the pool. So like we have players maybe, say, like Bellevue, and nothing to take anything away from Bellevue. But Bellevue is a small D4 school, and you might be really, really, really good at Bellevue and that stuff. However, you might have trouble even making the team. You might have been MVP of your team here, but you might have had trouble making your team here. Final thing that I'll do with that, because this is a true story. My first couple years coaching, I coached at Galesburg, and again, nothing to take anything away from Galesburg, but I coached girls basketball there. By the time I left, we'd built the program quite a bit. When I first got there, we only had 15 kids total. When I left, we were at 34 kids in the program. But I remember my first year that there was a girl, and she made our JV team. Okay, and in fact, she started on our JV team at Galesburg. Well, then I moved schools and I came to Gull Lake, and at that point in time, our girls basketball program was pretty stinking good. So that first year when I looked at, and I coached freshmen here, when the first year I got freshmen here, remember at Galesburg, we didn't even have a freshman team when I first got there. Okay. Here at Gull Lake, freshmen, I had 24 kids try out for freshman basketball that first season. That's like a lot, so we had to make a lot of cuts. So literally there were kids here that got cut from our program that were better than the girl that the freshman girl that was moved up to JV and was a starter on JV. So again, it just kind of, when you're looking at percentile ranks, it kind of depends on the pool that you're in. Okay? Good deal. Now Z-scores. Z-scores look like this. Z-score. A Z-score basically looks at how many standard deviations you are away from the mean. Okay, so if the mean was, say, 56 for this, whatever this category is, and the standard deviation was 8, good deal, and you scored at a 67, awesome, your score was 67. If I want to look at standard deviations away, or look at the Z-score, I would do this. I would do my score, 67, minus the mean, right? It's x minus x bar divided by standard deviation. So 67 minus 56 over 8, which equals 11 over 8, which equals 1.375. Awesome. So a Z-score of 1.375 means, again, you're more than one standard deviation of the mean. When I look at this transferred to a normal distribution curve, here is the mean, right? X bar or mu. One standard deviation over. Usually, if it's a normal distribution, it's 34% of the population. 2 standard deviations is right here. Well, this person's score was at 1.375. Good deal? So they really are above, right, this is the 86th percentile. They're above that. And we can find out exactly what percentile rank they are at by using something on your calculator, using a normal CDF. And that's something that we just barely got to, but I'm going to show you again on the calculator here for everybody else. So I have to do second and the vars key right here for distributions. We're doing distributions. And then we're looking at normal CDF. And what I do is I put the lower bound in here. So lower bound for this one is the lowest numbers possible on that side. So you could typically get away with just putting 0 in. The video I showed you showed how to do scientific notation really, really small. The upper bound is the person's score that we're going to put in, 67. The mean, the mu in this case, right? The mu is 56. Put that in there. And then the standard deviation we said was 8. And paste that. Oh, sorry, I did that on my home screen. That was bad. So second vars, normal CDF, 0, 67, 56, 8, paste. Now it's on my home screen. So for anybody who's just typing this in on the old calculator, when it says normal CDF in parentheses, lower bound, comma, upper bound, comma, mean, comma, standard deviation. Those are the things that have to go in. Your comma, again, is right above the 7 key, and those are your parentheses. Okay? So I'm going to go here, and I'm going to hit enter. and this says 91.54 or 0.9154, which means that their score of 67 is better than 91.5% of the people in this population. Okay, so you've seen a lot of this stuff. You're going to watch some of the videos. We're going to talk about this data that's stretched out like this. It would be data skewed to the right. If it's like this, it's data that's skewed to the left. So right or left depends on where the tail is. So scores that kind of stretch those things out. You know, because you've seen it, right? That it's 68, 95, 99.7. Those are the breakdowns for plus or minus 1 standard deviation, plus or minus 2 standard deviations, plus or minus 3 standard deviations. Remember again, you can use all your notes on this test. You just can't use your neighbors. So these things, better not see those. And yes, you do have to have your camera on while you're taking this. Okay, you do need to be able to see you so that I know that people aren't cheating, unfortunately. Good deal. Now, for those of you who stuck around, it's 26:14 mark. Awesome. So we're going to put this in here. Watch, take a look. Don't tell anybody else. Don't tell anybody else. But this is, again, this is only for 2020, for November of 2020. If purple butterfly, we're going to say that, purple butterfly. If you email me purple butterfly, you email me those words, purple butterfly, I'm going to give you, let's see, let's go this way. For the first 10 people, don't be sharing it. They got to find it on their own. Do not call that person. Do not tell that person. Okay, so you send me in an email the words purple butterfly. I'll give you 5 extra credit points. Isn't that nice? For the first 10 people. However, with that being said, I don't know how many people really watch this stuff. So if you're the only one that does it, if you're the only person that actually watches it this far and pays attention to everything, I'm going to give you 10 extra credit points. Good deal? Okay, except now it's even trickier. You need to email me the word purple orangutan. I'm not going to write that on my paper. We're going to see how many people actually listen to the video. Maybe it's just you. Hopefully that will help. It's Mr. Bells. Talk to you later. Bye.